Okay, Cup, welcome to the 15th and the final class of emerging technologies for lifelong learning. And this is where you get to present your sort of like a term study, right? Independent study or term study to your peers. Now, the way we're going to do this is everyone's going to get about a 12-minute slot. 12-minute slot, that's inclusive of everything, from one person to the next. So when we start, we'll count the clock at 12 minutes each, right? And during which time you will start with your presentation. Again, the idea here is you get to control your narrative with a prepared set of slides, right? But however long that it takes, it's up to you. Okay, you can just present for 1 minute and open the floor. You can present for 10 minutes and open the floor, as long as you have enough time to elicit response. Okay, now the way the grading will be done, you will be grading your peers, right? You'll be grading yourself as well. In fact, the sheet that your TA has passed on will have all your peers, right? And then just go in that order. And you're encouraged to evaluate yourself as well. Well, there are 3 categories, right? There are 3 categories. Remember, we talked about how we assess the quality of your work, right? There's a professionalism, right? If you assign a project, if you're looking at a topic, you've done a good job of doing all the survey, it's complete. So it's sort of like completeness, thoroughness. It's a professional degree of coverage that we're looking for, right? So that's one part, right? And the other part is, again, the wow factor. The second aspect of quality is the impact. This is really innovative, right? We're looking for innovative take on the subject. We're looking for some kind of how this can be something that really excites everyone in the room, and we'll check. And this is about the subject itself. It's not about the presentation. It's not about flashing presentation. The content itself has to be exciting, right? From a technological, from an innovation perspective, from how it's going to change the technology landscape, or perhaps present a significant contribution to addressing say climate change or sustainability challenge and whatnot. So this is sort of like the impactfulness, the quality of that thing. Okay, how much you can bring that to the table. And the third part is a little bit like a representation kind of thing, right? So the first 2 parts about the content, okay? The content, and now it's about the presentation and how each speaker is able to maybe elicit response and interact with the audience. Now, to be fair, it's very difficult, and even I can't get you guys to interact very much over Zoom compared to in class. I mean, this is very obvious. I think Basai students are quite proactive when they're in class, when they're in Zoom, or when they've been Zooming for a long time, they get to be a little bit laid back. So that's a little bit of a challenge. So the presentation, the interaction, the ability to get, again, a positive and negative comment and so forth. Now, so these are the 3 parts, right? And number 1 is the first speaker, number 2, and so forth. I want you to add the final column. It's not in the form. Add final. The final column is constructive or comment, feedback. Okay, so it could be feedback that you actually say in class, and then you write that down in the evaluation form. Okay, now this is different, right? The content part and the presentation, the content thoroughness, the content, the impact aspect of it, and the presentation, that goes into the scoring of whoever gets scored, right? But if you put comments, you are the one getting the score, right? It's your contribution. Okay, so it's different, right? So the first 3 columns you rate your peers, and all this peer evaluation, including my evaluation and your TA's evaluation, will go into the scoring of individual person. But then I will actually score, or the TA and I will actually look at if you're making perceptive, critical, okay, understanding and feedback. Okay, so for the feedback, I give you two keywords, right? Perceptive and critical. Okay, perceptive, that's very important, because in today's culture, it's very easy to look at something and just start trolling right away, right? So you don't really even understand what you're commenting on, and you start commenting on. So perceptive is a little bit like, it's retention plus, right? You understand what was delivered, but you actually also are very perceptive about what the key message is and what the real story is, and you are insightful in that sense. Okay, so your insightful feedback has to be perceptive. That's part one. The second part is critical. Critical doesn't mean negative, right? Critical means analytical. Okay, so it's sort of like analytical, critical. So you're critical, not necessarily like, oh, this sucks, no, this is no good. That's not the critical I'm looking for. Okay, critical I'm looking for is something that requires a little, quite a bit of thinking, right? This is very like the success of this project, or the success of this approach will likely depend on, you know, 2 or 3 maybe supply chain factor that has to be evaluated. It hasn't been evaluated, so we don't know if this is ready for Thailand, because we don't know this infrastructure or the supply chain framework supports it, and so forth. So this would be the critical part, right? So perceptive and critical, all right? That's what I'm looking for your insightful contribution. Now, this is a little bit of like a bonus. So sometimes if you don't have anything to say, don't say. Just, you can leave it blank, right? But it's sort of like a bonus for you as a quote, peer-to-peer. Peer-to-peer is going to become a lot more important. Okay, and this is something I haven't touched at length. But in the future, the idea that you submit the work to sort of like centralized authority to evaluate, that's maybe not diminished, but you know, it's sort of like it's going to be there, but certainly peer-to-peer evaluation. Okay, it used to be like this. It used to be that there's one authority, right? There's one authority, and everybody has to submit to it. Okay, and then after that, they're sort of like more committee kind of selective. This is where you have some kind of professional board, like a peer accountants get together and they create an accounting board, and that serves as an authority. So it's not just one guy now. It's sort of like peer selected, but once it becomes peer selected, that serves as an authority. Okay, so the first kind of authority, you know, there's no peer. There's just one guru, right? Knows everything about accounting. And then you have to say, okay, is this good? Is this bad? The second stage is when you peer professional, whether it's legal, accountants, data scientists, right? Get together and then create some kind of a board, like a committee, right? So this is something you see in things like Wikipedia or GitHub, or all kind of things like forking in Bitcoin. For example, that's also, I think, committee decided, but the committee are voted in by peers. They're not you know, authoritarian. So that's and then at some point it gets to things like peer voting, okay, and a system like voting favorite restaurant or something. Although that can be manipulated, so I warn you about that. A lot of times it's not a real peer. It's robot peers. Okay. So peer-to-peer is going to become one of the skills you're going to have to master. You have to be both a contributor and receiver of peer-to-peer evaluation. Okay, so with that, let's again. I'll let Pinat count the clock, and at minute 12 or minute the last minute of the first guy, the second person will come up. So let's say at 9:17, who do we have?
Okay, at 9:17, Panpisha will present.
Very good. Okay, so tell you what. Normally, I always have my camera on. Now it's opposite. I'm gonna turn my camera off. You're gonna have to look at all your friends' feedback. You will get no reaction from me. I have no response. Okay, you have to get all your response from your friend. So Panpisha, I give you a few seconds to set up. At 9:17, you have the floor. You have everything. You have the screen. You have the and if we all yours, and you manage. So if you add 17 to 12, there you go. Okay. Good luck.
Thank you. So I'm gonna sharing my slide. Oh, it's quite funny. So can everyone see my slide?
Yes, we can see.
Yeah. Okay. So I'm gonna start now. So yeah, today I'm going to solve the most common problem in the world, the plastic waste. Especially the PET plastic or polyethylene terephthalate. How common is? I bet there is one thing around you that is made from PET. Like mine is this water bottle. Yeah, PET is one of the most produced and used plastic in the world because of its various advantages such as transparency, durability, low cost, and easy processability. However, as the product and consumption of PET continuously increase, the plastic waste management capability is not coordinated, leading to the accumulation of millions of tons of plastic waste in the terrestrial and marine environmental. It evaluated the risk of environmental pollution and climate change. Therefore, to solve the problem, several technologies have been developed and researchers have focused on the biodegradation of plastic waste by pesticide. So try to imagine if you can just spray some liquid on the random plastic and boom, it's gone. So that should be great, right? But due to some exhibit limited PET degradation performance from many factors like temperatures, pH, stabilities, makes them to be not practical for now. But just for now, because researchers discover ISPTs enzyme synthesized from adelina saccharomyces, which reported to have the highest PET degradation activities under room temperature. Out of all enzymes reported up to date, what I meant is that maybe the plastic degrading state I mentioned before will maybe come through after some experiment. Besides its high degrading activities, ISPTS has such a low thermal stability that still limits its utilizations for plastic waste management. So what I'm going to do is to use the structural information on ISPTS, develop a rational protein engineering strategy using several ISPTS variants that was screened for high thermal stability to improve the PET degrading activities. But before I'm going to mention the process of all these experiments, I think I should explain something beforehand. The rational protein engineering is an umbrella term in protein engineering, which attempts to create improved protein molecules based on the 3D dimensional structure and the relationship between structure and function. So everything before using in the real life, we got to do some experiment in the computer that help you to improve some specific protein. Yes, that rational protein engineering. So let's walk through the methodology that I have planned. First, to identify the key structure features that affecting the low thermal stability of the protein. Because the stability and activity of proteins are in the trade-off relationship, we focus on structural regions located away from the active site, which the picture that I show is showing that specific part. Then after we know the thing that is a key factor, then we can generate new protein variants with iterated condition using rational protein engineering. After we can do it, design the rational design, we then examine how the rational design mutations described above affect the thermal stability of ISPTs by comparing the melting temperatures of the iterated variants, then do some extra experiment to make sure that the change of melting temperature is caused by the mutation, not other part of factor. The rational engineering is repeated to improve the thermal stability. Then investigated the effect of increased thermal stability on enzyme activity by measuring the PET degradation activities using a PET films at 30 and 40 degrees of the iterated variants, and once again repeat all the rational engineering so that we can make sure that it comes from the mutation, not from the others outside the factor. Then testing the durability of PETs for a long period of time with both heat-activated and unactivated experiment, because enzyme is produced from protein, so it may be different after we give them some heat and not. Then there you go, the IS-PETs variants with high thermal stability and high PET degradation activity through a rational protein engineering strategy. So that's all for my presentation. Thank you for your attention, and I want to give you guys to see some of the. That's it. The thing that I show in the slide is actually a reference for all of my work. It's a paper that I actually sent you before. Yeah, if you're interested in the topic, please check that out. Thank you. Yeah, so that is all of my presentation. So what you want me to do next is doing some discussion, right? Thank you for your clapping emoji. I really appreciate it.
I have a question on the enzyme you talk about. So after you use the enzyme, you like, for example, you pour it on the plastic, right? What is the structures after the pouring process? Like, it's gonna deform its structures, or it's just gonna like gone? Can you explain on that part?
Okay, that's a very good point, because one of the problem of this process is about the product and the byproduct after doing this hydrolysis enzyme thing, because sometimes the product may be dangerous to environment, but due to the research, the ISPTase is actually one of the enzymes that can just cutting the plastic into smaller molecules, which is actually not dangerous for the environment. I'm sorry, I'm very sorry to say it, but I cannot remember the name of the new structure, but it not will just clear, it just becoming smaller particle that actually can be easily to destroy. Yeah, that's it.
Thank you.
Yeah. That question actually good, because like there's a lot of experiment that really concern for that, because as I mentioned before, the hydrolysis byproduct is actually not safe for the environment. So new enzyme and protein are researched and covered now, because like they want to have the best protein, the best enzyme, or the best protein from some bacteria so that they can actually solve this problem practically. And that actually, but in the first place, I want to shift this project to be about researching the new type of bacteria or proteins called metagenomic. It's so that I can like research the new bacteria in our faculties. Like I just want to collecting samples from my friends and like on the table of the students or like teacher chair like that, so that I can like discover some plastic yeah, kind of that. But that's a lot of work, so I just decide to shift my work down here. Yeah. So is there anyone has any questions? Teacher Phumjai, you can actually ask me.
Okay, I was hoping to stay out, but very good. No, what's not clear though is how this is in relation to you're describing a piece of technology, and there's some gap about how this thing came about and so forth. How would this be something that you take part in, right? Are you going to take a research into this, or is it something that you can start thinking about trying to promote it as a viable technology that current industrial partners in Thailand are already able to do? They just haven't maybe read this paper, but once they read this paper, they just go on just like that. It's just, you know, where are we? Remember, we have to talk about technology in terms of emerging technology, right? So you talked about the technology, you haven't talked about the emerging part. Where we are we ready? What is required to make it ready? What is your part to make this ready? You know, that sort of thing. Can you elaborate a little bit on that? Or, you know, right now it's let's say the science is sound, okay, the science is sound, okay, then, you know, as we talked about in the class, there's a step from science to engineering and all the way to marketing and social transformation. Where are we on that journey?
Okay, so let's say first that where are we? Currently, we are on the process of experimenting, like exploring new enzymes, try to make medical, do something that I do right now is whether it's a direct evolution or rational evolution, they try to make its enzyme that can be optimal to the conditions of that country or that place to destroy the plastic. And what I can do as I want to emerge that, actually I want to be part of the experiment. Before presenting to this class, I actually met my friends who currently do this project. Like they do internship with the real science lab, and it's just so like I just confused at first, like, oh, that's what I want to do, and they were like, yeah, and then explain and taught me about the thing that I do right now. I actually get the new protein right now. They call it NCs 8 or something, because like they use the sample from the human mouth, and they just like do the direct evolution, like press the X-rays to it, like, okay, you need to mutate on and also do rational evolution, because that I think you know the university is Tech. Yeah, so my friend is like we are high school friend, like my ex-classmate, like schoolmate, and he just like, okay, so if you want to do this, you need to go through that and he's like tell me all the process, and like, oh, okay, I know better because of it. And I think if I want to enter that experiment, I think I can, because like I know someone in that lab, and I just like, okay, if I want to immerse that, I'm gonna do this project. But maybe it's hard, but yeah. So but a part of myself, if I want to be the process of like experimenting and working on it, if I don't have enough knowledge,
I think in your presentation, you should do a little bit of, you know, this kind of line again, from science all the way, and say, you know, this is where we are and so forth. again, you're trying to do, but there's a lot of things you have to do, right? You not only do you have to sort of like, let's say you have to you came up with a perfect enzyme that would do this. How would you manufacture it at scale, say, right? And then how would you deliver it? There's also, remember that the biotech class, it's not enough to have something, it has to be there, right? So this thing has to get to your gut biome without being eaten by your digestive tract or something like that. So how do you get the enzyme into a say generic plastic disposal sites? There's so many things. There's so many things. Now, it's not for you to answer, okay? It's for you to map out what challenges are there, and then you can gauge the readiness of technology by seeing. Remember I told you about this sharp curve. There could be 100 hurdles to overcome. Maybe if you get past the first 38, the project takes off. Yeah, that sort of thing. Okay, where are we? It's an amazing piece of technology. It's right now, it sounds to me like an amazing piece of science. Okay, it hasn't got to the technology part yet. So how far are we? 5 years, 10 years? It's always good to have that kind of thing. Okay, and again, same comment with with last time. You tend to jump right in. Okay, in a 12-minute presentation, allow yourself no less than 2 minutes to set up the audience, set up the context, set up where you are. You're not going to run out of time to explain your thing. Okay, but if you spend the first 2 minutes wisely, you won't take that much time to explain. Okay, set up your audience. Okay, set up your audience. This is this whole spectrum of thing, and today I'm just going to focus on maybe designing, or sort of like designer protein is the theme of today or something like that. Okay, so very good. Okay,ครับ. Sorry, I'll try not to comment so long. So we'll do things on time. Okay, and okay, finally, be very clear about what you mean by we. We as in the author of this paper, or we as in you and your friends, or okay. Okay,ครับ, very good job. Look forward to reading your report. Okay,ครับ. Okay, I'll fade out in the background to the background. Bye-bye.
Okay, so it's my turn.
Okay, it's your turn now.
Okay, thank you.
Yes.
Can everyone see the slide and hear me clearly?
Yes, we do.
Okay, thanks. So good morning, everyone. Today I'm going to present about the emerging treatment of ADHD using haptic globes and a VR game. First of all, let's get to know ADHD. ADHD, or Attention Deficit Hyperactivity Disorder, is one of the most common childhood neurodevelopment disorders. It is usually first diagnosed in childhood and often lasts into adulthood. Children with ADHD may have trouble paying attention, controlling impulsive behaviors, and being overly active. And 6.1 million children were diagnosed with ADHD, and boys are more likely to be diagnosed with ADHD than girls. There are two types of ADHD treatment. First one is medication, and the second one is behavior therapy. 3 in 4 US children with current ADHD receive treatment. 62% of them take medication, while 47% receive behavior therapy. 32 receive both medication, and 33 receive neither. So talk about medication. It doesn't cure ADHD. Still, it helps boost the ability to pay attention, slow down, and have more self-control by targeting two brain chemicals, dopamine and norepinephrine. However, ADHD medicines have common side effects which affect kids' routines, such as loss of appetite, trouble sleeping, moodiness, or etc. So Behavioral therapy is another option for ADHD treatment. Kids with ADHD benefit from therapy to learn and practice skills like staying organized, managing schoolwork, or dealing with stress. According to American Academy, there are three basic principles to any behavioral therapy approach. First one is set specific goals. The second one is provide rewards and consequences. And the third one is keep using the rewards and consequences. So a digital therapeutics is an excellent option for behavioral therapy. It may offer improved access, minimal side effects, and low potential for abuse while providing targeted treatment options for improving cognitive functions such as attention. There is a paper about the effectiveness of a digital therapeutic as an adjunct to the treatment with medication in pediatric ADHD. STARS adjunct was a multi-center open-label effectiveness study of AKLT01. It is an application and video-based treatment for inattention. As an adjunct to pharmacotherapy in 8 to 14-year-old children with ADHD on stimulant medication or not on any medication, children use AKLT01 for 4 weeks, followed by a 4-week pause and another 4-week treatment. So it's about 12 weeks for the trial. All participants were instructed to play AKLT01 for around 25 minutes per day, 5 days a week for each 4-week treatment period. Within each day, the 25-minute session were divided into 5-minute sessions. So it's 100 missions in each 4-week treatment. The primary outcome changed after 4 weeks. Then it remained stable during the pause and improved with a second treatment period. In next step of the treatment, we can improve video game therapy by combining haptic globes and VR. To understand how it works, we need to know about the brain exercise. Brain exercise, a movement combining balance, coordination, eye, and sensory exercises that specifically involve the function of the cerebellum. Each program provides a series of exercises to develop the brain and facilitate communication between the two sizes of the brain. Haptic globes reproduce a range of sensations in virtual world, including texture, pressure, and vibration. By combining video games for ADHD treatment with haptic globes and VR, kids will be able to experience a bigger and more realistic world. The research shows that brain exercise can improve concentration of focus, memory, academic ability, relationships, self-responsibility, organization skills, and behavior in children with ADHD. So to summarize, the new possibility of ADHD treatment is upgrading video game therapy to the VR world with haptic globes. With its solution, kids with ADHD can do digital brain exercise effectively and more realistically. So that is all from my presentation. And I think that there someone in here have experience in ADHD or have someone you know who has ADHD. So is there anyone can tell us more about the ADHD story? Okay, or anyone have any question more to ask?
Has this been used anywhere yet? Like, yeah.
From now, there is only a normal video game that you play on the smartphone or iPad. And haptic globe is now has a prototype from Facebook or Meta. They have shown us the prototype that they can create for their metaverse. And I think we can adapt that technology to help ADHD kids. but it hasn't has this exact technology in the real world now. Okay.
Yeah, I tried to stay out again, but couldn't help it. Talk a little bit about the haptic gloves element. Gavin. Is it where you're coming or?
Yeah. I found a haptic gloves from the advertisement of Meta, and I think that it can improve the sensory for children that can make the digital world to be more realistic. And like right now, the Meta has improved the prototype of it. So I think in soon we can have the real haptic gloves that we can buy and we can use in the metaverse. Yeah.
How expensive would that be?
I'm not sure about the price yet, but yeah, I can show you this article. This is how the haptic gloves look like that make users to feel the object in the metaverse. Yeah.
I have a question on the haptic globes. Since most of the research you presented today claims that this gaming innovation or the globes will help the children with their diseases, right?
Yeah.
My question is, since the product is yet launched or tested by many of the children's, how can these stats that you presented is real? And another question is that since it's pretty high-tech technologies for the industries and many of us, since the metaverse is quite far away from the realistic parts right now, since it's required many of the stuff to emerge first in order for us to really get into the real metaverse. Is the product gonna live that far for the users to actually use them, or is there gonna have other products that will launch in the market which can have a better features than this haptic globes? And the last part is that the technologies, I believe, is quite expensive. How, or is there any ways that these globes can have a lower cost so that every students can who have this disease, the ADHD disease, can have like the access to these devices? Thank you.
Okay, so to answer your first question, there is the number and the scale that we can measure how good or bad of the ADHD is. IRS overall, since we have like in that research they use two measurement is ADHD RS and IRS. So I'm not clearly understand about that measurement, but we can use that measure to see the development and the improvement of ADHD kids. And for the second question that you told us, like the metaverse is still far from us. From my idea, I don't have to use the metaverse because I think metaverse won't be benefit for the children. They don't have to connect with other in the metaverse world. But I think the things that will benefit students is the sensory that they can have from the haptic globes, and they can play individually in their video game with the VR. So I think it's not that far away with just the game shift into the VR and use the haptic gloves as a gadget for them to play. And for the price, right now, I have to say that I'm not sure about that. And I think in the future, when they have many haptic gloves, have many companies that can produce haptic gloves, the price will go down and it will be affordable for children, I guess. Yes.
Thank you.
Okay, thank you for your questions. So that's all of my presentation. Thank you, everyone.
Okay, so can like you guys see my screen?
Yes, we can.
Okay, so today I'm gonna talk about SAR interferometry to measure the carbon stocking in the forest areas. Before going on to how it measures the carbon stock, let's look at what SAR really is. SAR, or synthetic aperture radar, is a type of active data collection of which its sensors will generate energy on the surface and then measure the amount that it is reflected back. It works a bit differently than the normal optical imagery satellites. You can see here on the left-hand side, it will be optical image, and on the right-hand side, it will be radar image. It has different wavelengths than normal ones. Wavelength that used in SAR is approximately about 1 centimeters to 1 meters, whereas optical sensors is about 1 micron. This difference is why SAR can observe through clouds and storms. Secondly, since SAR produces its own brightness, its antenna transmitting the radio waves, it can work throughout day and night, whereas the optical imagery cannot. And the optical imagery is dependent on the thermal radiation, causing the effectiveness to vary upon the sun's angle. And lastly, the image produced by SAR satellites differ from normal one as SAR sensors are side-looking. You can see it from the image. Moreover, the main thing that's important, it's the resolution of the radar data is relatively related to the connection between the wavelength of the sensors and the sensor's antenna length. In this case, if the wavelength is stated, meaning like it's set, the longer the antenna, the better the image resolution would be, which means that to get a good image, you would need an antenna that is about 4,000 meters long. That wouldn't be a practical thing to put up in space. This is why SAR is developed. SAR combines shorter antennas in different acquisition, gives a larger antenna in total than the normal one, so it allows it to produce a high resolution image. Moreover, the main thing that's important is moreover, other than knowing the main component, we need to know how it functions. Its main mechanism is polarization and scattering. As mentioned before, SAR has the ability to capture the data in different kind of environments. Thus, this happens
because of analyzed polarization being controlled in the input and output path. The polarization means the way or the angle of the plane that transmit the electromagnetic waves oscillations. In SAR, normally linearly polarized is transmitted. The V and the H, vertical and horizontal, are indicators in controlling the polarization of the plane. This is really useful because for different location, the energy that is reflected back will be different. And so if in different location, if we could move the plane to have the like different orientation according to the environment, we would get the best data. For example, rough location would have to emit the signals vertically and receive the signal vertically. So its polarization, it's V and V, because this is how they scatter. Whereas in forest, volume scattering occurs, therefore cross polarization must be used, whether it emits vertically or horizontally and receive opposite direction from emitting. So like if you emit the signal vertically, it have to receive horizontally, but if you emit the signal horizontally, it have to receive vertically. Hence, it is important to see signals emitted while scattering to the forest. Wavelengths are very important. Some wavelength will go as far as the top layers of the trees. However, some, like in this example, the P band, it will go much deeper. So now let's talk about the application. I'm applying these SAR satellite to monitor the carbon stocking in the forest. It is a must to do this because this allows us to keep track of carbon changes in the forest. It is hard to do it any other way, like data sampling. Thus, SAR is a tool to have analyzed the sources and the sinks of the carbon. It is found that 80% of the carbon is stored in the forest worldwide. This is a huge number. Therefore, we must know the carbon stocks. I wasn't able to get any of the data. I wasn't able to use any of the data available directly from the SAR inventory. Therefore, this is the indirect data from the network. Therefore, I'm going to use the LOS-2 satellite to measure the bands and so the resolution it gives. We will study the Kizildag Forest Enterprise, which is located in the Western Mediterranean sub-region of Turkey. It is about 53,290 hectares. As mentioned before, since it's the forest, we will use a dual polarized SAR, meaning either VH or HV. As you can see, there are mountains, and as you can see on the left-hand side, there are mountains and agricultural areas. This is the image got from the satellite. It shows about 2.03 metric tons of carbon stock per unit. The average of the total carbon stock is 133 hectares for the forest. If you look in depth, there are carbon stock in the low altitudes area. However, the carbon stock will rise if the altitude rises. In this case, this could be because of the trees grown here, because the main tree here are conifers and oak. These can store a lot of carbon per unit. However, it is less compared in the map because this was controlled by the forest enterprise in growing this kind of planets. in growing these kind of plants. This is how basically it works. But to make it more interesting, I'm going to use PyroSAR. It is a Python framework for large-scale satellite data. This will act as my data inventory to map out the area. And so I'm able to analyze and estimate the carbon stocking by myself. This will be reflected later in the report and the recorded video. Thank you for listening. If you guys have any questions, you can ask.
I actually have no knowledge about this, so I just want to ask, like, how the SAR satellite measure the carbon stock. I heard that you mentioned that it is the best optimal, like the picturing process, but how it relates to carbon stocking.
Okay, so you can see the color here. If it's red, then it's like really low, but if it's like green, it's really high. And how does it measure? It's measured by the plane. So it emits the signal, and the energy reflected back will show you these colors. Yeah. So different locations show you different kind of like signals.
Okay, thank you.
I think she meant the actual mechanism. I mean, it can do that. Have you studied the actual mechanism, how the SAR signature translate into carbon stocking?
That I have to still study.
Okay. Okay. For all of you, do send your presentation just as you start your presentation, because sometimes the audience like to look at the thing and maybe go back to different pages. You know, sometimes. So all the three speakers, please send your presentation, and the next speaker also send the presentation before you start. I think we're waiting for Pinat to announce the next guy.
Okay, then Charlatan, you can go next.
นัดบอกตอนกลับคนกลับจบนิดนึงก็ดีบอกในที่สุดท้ายเดี๋ยวเขาจะได้เตรียมตัว
Everyone, you can see the next queue on the chat. I will post it here in Zoom chat.
Okay, so the IoT solution that I'm going to be presenting is about the shipping operations. The topic is the new standard of measuring parcels. So the pain point right now is that the shipping parcel measurement standard is totally at randoms. This lead to an inaccurate pricings, lead to the unfairness to both to the customer and service provider. Also, the service provider also lose their credibilities and customer loyalties. And why is this important? Fun fact, capturing accurate dimensional measurement is actually a core of a successful shipping operations. Whether a shipper use vendor box or its own standard size packagings or packed in box of various size, it needs accurate dimensional data to ensure compliance and avoid fine or unfairness to both sides. So what is the root cause? First, it is the equipment. Equipment sometimes are in a cooler or under temperature conditions. It is not regular calibrating scale. There's various size of parcels to be measured. Secondly, about the parcel materials. There's no universal standard of packaging materials. And when you measure one item, most of the time you will assume the same weight across all the variants within the product families. And lastly, the environment. There's unpredicted moisture conditions. You measure in an environment the product is not intended to be stored in. And sometimes when you're measuring the parcel at the warehouse, the higher shelf is significantly warmer than the lower shelf. So from the customer perspective, from me conducting interview with the user insights, we found that the weight and dimension actually has zero standards, especially when picking up the parcel at the front door. They just use their own guesses. And the most importantly is the customer right. Many of the customers still doesn't know that they lose benefit from this factor. And lastly is the human errors. Sometimes the employees see their own regular customer, so they wouldn't even bother checking for the parcel dimensions, and they just charge the same price as before. Therefore, for the IoT solution that could potentially solve this problem, I came up with these three solutions. Firstly is the tablet camera audio sensor. The system can show the dimension from the camera view. The camera system will utilize the speaker and microphone sensor as a distance detector to extract the information needed for the correct sizings of visualized measurements. And acoustic pulse measurement will be applied by using the microphone and its vibrations. From the experiment, there's only 0.6 of inaccuracy. The second solution is the light cutting methods. The widely spread laser beam is projected on the measurement object at the conveyor belt to measure its cross-sectional shape, and the reflection from the object is received by the CCD. So what is CCD? CCD is a charge coupled device, a light-sensitive integrated circuit that captures image by converting protons to electrons. A CCD sensor breaks the image elements into pixels, and each pixel is converted into an electrical charge whose intensity is related to the intensity of the light captured by that pixels. And back to the IoT, since the 2D data of X, Y, and Z axis are measured simultaneously, there's no need to move either the sensor or measurement object. It can also scan and detect the depth and roughness of the object too. And the last solution is the LiDAR sensor. So what is the LiDAR sensor? The LiDAR sensor emits pulse light wave from a laser to the environment. This pulse bounces off surrounding objects and return to the sensor. The sensor uses the time it took for each pulse to return to the sensor to calculate the distance it traveled. And here's what it looked like. And how to use it to make it suitable for the parcel dimension measurements is to place the AR LiDAR cameras on the top, width, and length of the conveyor belt. Therefore, the customer simply places the box on the belt. And when setting up, you need to calibrate the system first with something with a fixed high accuracy to match the camera pixel with a real object. About the accuracies, there's plus minus 1 centimeter of inaccuracies. And this is only from the example of the iPhone LiDAR. There's still many more specifications of LiDAR. The more expensive the LiDAR, the inaccuracy can reduce to 0.5 to 1 centimeter. After all the comparison, the most suitable IoT to solve the problem of unfair pricing in shipping delivery parcel is the LiDAR camera. Here's the main reason why this is the best solutions. The LiDAR IoT has a high accuracy of dimension measurements. Many big companies use this technology and apply it to their industries. The technology is not too high of a cost. It is easier to use and install, and many developers and researchers are still improving and researching mainly on these technologies. There's a large community of people who use and are interested in these technologies and integrate it into a wide range of projects. And I believe that if this IoT was first used in delivery transportation and work efficiently, it will bring in a lot of tractions. Also, customers from other transport that doesn't use this IoT will demand and automatically make this universal. Thank you. And it's Q&A time.
I have a question. Can you go back like the last slide before Q&A? Yes, the slides. Since you mentioned that it is low cost and easy use and install, can you give an example company that in Thailand that currently use these IoT solutions?
As of now, there's actually not yet a company that a shipping company that use this LiDAR camera to measure their parcels. And what I mean by low cost and easy to use and install is compared to other two solutions. For example, these solutions, this technology is better than LiDAR, but it is much more expensive. And from this example, it can detect the roughness of the object. However, the parcel is unnecessary to have the roughness of the object since it's just a square box.
Mm-hmm. So yeah, the solution is more like have a lower cost than the other solutions you mentioned. It's still a high cost for the industry to adopt this solution, right?
Yeah, so
okay,
from my perspective and research, the LiDAR camera will be the most feasible to this problem.
Thank you.
Is there any more questions, or if you guys want to know something else, I can go through the slide that you want to know.
So about the IoT things for transportation. So is these three things that you present and mentioned is gonna be like the next, like the crucial part of changing the transportation field industry? Because like you mentioned just last slide that it will be the client will require it as fundamental things after. Is thing that you present is the one of that, or it may be another one like in the future that can develop after this?
It can be developed after this, and because of this solution is actually this problem is actually never been solved, because people mainly from this slide that people are not aware of it, and they just ignore the problem and they don't think it's a big factor. However, I see that this problem, if it can be solved, it can bring a lot of opportunities to the both the customer and delivery operations. So I find these three solutions that could potentially solve, and from my perspective, this solution can solve and bring lots of benefit, and it can actually be executed and used in real life. Does that answer your question?
Yes, of course. Thank you.
I think you can sort of like help set up the stage that this is one of those things where the technology may work, but whether or not it is going to be economically in demand enough to create a new business model, that's certainly something that has to be explored. So I think yeah, you done a good job saying that it's completely viable, it's completely doable, but whether or not, you can make this work economically. Okay. How cheap are LiDAR cameras now? Can you buy LiDAR camera from Lazada? Or, does it get to that point? Are people getting to be angry or aware that their shipping cost is not reflective of whatever, they want a more competitive shipping? Or right now people are happy to pay the shipping fee that most consumer face. So it's not a big deal to them, or that sort of thing. So it's not just the technology itself, it's the commercialization, and that's quite a bit of work. But certainly the most important thing is the technology. Okay, it's the technology is the necessary, but the commercialization, the economics of it is the sufficient condition to make it happen.
Yeah, like this technology, the LiDAR camera has been exist for a while. But however, I see that with a few adaptation, and it can be applied to another business model, and it could be a benefit to this industry. And it comes with a cheap cost, and it is much easier access than before. So I think that it can be applied to the shipping industry.
Okay, I think it's about time. Next is Chayanan, you can go.
Hello, everyone. So let's start my presentation then. Okay, so first I would like to ask the audience, or you guys first, like how many times have you have to change your phone screens, like it shattered or the screens break? If yes, can you just react or open your microphone? Oh.
Change it a lot, like every year.
Yeah, it's a pretty kind of boring things, right? To have to change a lot, like your phone screen and other stuff, right? So I would like you guys to close your eyes first and then imagine if there is substance that would make your phone screen indestructible, like if it's fall, it's never gonna break. Have you guys imagined something like that? It's pretty cool, right? So with this innovation I was going to introduce for you today, it's quite possible to make that happen. So this is 2DPA1, the innovation breakthroughs that was introduced by the MIT researchers. So let's start with the closely, like the initial terms of the polymers first. Okay, let's go. Okay, so polymers. The polymers is a combination of words between polys, which mean many, and meros, which mean part. Combining the two words, the terms mentioned is meaning like many parts. So this is polymers. So polymers is a material composed of a large number of small molecules of the same type that when polymerized, it's form a chain-like structures. As you can see on my slides, there's a linear chain-like structure, a branch chain-like structures, casting, and network. So polymers have existed in the natural world since the beginning of time. Cellulose, starch, like for example, the starch you found in rice or something like that, or even natural rubber, like in the car tires that you drove every day to work or to school. So this is a natural polymers. A man-made polymeric materials have been studied also since the mid-19th centuries. And for today, the polymer sectors, if you couldn't imagine, is larger than the copper, steel, aluminum, and the other industry combined. Yeah, it's a pretty big industries, I know. So polymers, how do polymers form? Polymers form in the different type of ways. So these polymers grow by attaching more molecules to the ends. As I mentioned, form chain-like structures. Once the polymers have been created, they can be molded into three-dimensional shape objects using injection molding. Here you can see that the injection molding use the screw rotates and push the plastic into a mold structures, which came up as like the structures that you wanted it to be. So scientists have long speculated that if polymers could be forced to grow into two-dimensional sheets, they would produce extremely strong, lightweight materials. Decades and decades of research in this field have been putting on to this research, but however, led to the conclusion that such sheets were impossible to build. The one explanation for that is when only one monomer spins up or down away from the plane of the forming sheet, the material begins to twist and expand into 3 dimensions, making the sheet-like structure lost. So introduce Professor Michael Strano of MIT and his colleagues. He procedures that allow them to create a polymerized a 2D sheet. So going deeper into the 2DPA1, which is this this novel material, I would say. So first, what is it made out of? Melamine. And melamine is a chemical with a ring of carbon and nitrogen atoms that is used to create the monomer building blocks for this substance. Under the right conditions, these monomers can develop into 2 dimensions, resulting in a disc-like structures. These discs stacks on top of one another, held together by hydrogen bonds between the layers, resulting in astonishingly stable and powerful structures. Okay. Getting deeper into the unique properties. The new materials has unique properties in three ways. So starting off with the elastic modulus. So the terms elastic modulus is a term which measures how much force it takes to distort a material, meaning like to break the material. So it was discovered that this material is to be 4 to 6 times stronger than the structural steel. And they also discovered that despite having only 1/6 of the density of the steel, its yield strength or the amount of force required to break the material is twice that of steel. Another cool features of the materials is that the gas impermeability of the 2DPA1, which is meaning like it doesn't allow gases to pass through, since the structures of this material is made up of monomers that lock together like a Lego structures. Imagine you put 2 Legos together when you attach. It's very hard for you to crack it open, right? Since it has a very small gap and it has a high pressure between each Legos when you put it together. So that is its cool features. Now, as you has followed science closely, this 2DPA1 may sound oddly similar to the graphene, as every one of us has learned already in this field. But however, the 2-dimensional sheet materials seeming, no. I would say like, however, one of the graphene limitations in the industry that isn't that great compared to 2DPA1, it's scalability. So the graphene has to be generated in high temperature ovens, the temperature that can reach over 1,800 degrees Fahrenheit directly on the surface of an object. This is pretty inefficient in terms of scalability. However, for the 2DPA1 materials, you can put like, if you put enough starting material to produce 2DPA1 in bigger at a room temperature, we can make kilograms of this stuff easily In other words, the conditions required to produce 2DPA1 are similar to those required to produce most of other plastics. And because of this material can self-assemble in a solution, any engineers can produce enormous yields by increasing the number of initial materials. Okay, now this is the last part. So since the material is extremely strong and if it ever makes its way into the hands of consumer electronic manufacturers, it won't be long before a code of 2DPA renders smartphones virtually indestructible, or at the very least, shatterproof. Furthermore, the material would allow for the creation of outer-thin covering capable of completely preventing passage of waters or gases. This type of barrier coating may be beneficial to metal. The material's unusable property may make it suitable for a wide range of applications such as long-lasting coatings for vehicle components or mobile phones, as well as construction material for bridges and other buildings. And this is the 2DPA1, the newly discovered types of 2D polymers. And this would be the end of my presentation. Do you guys have any question? I can go deeper into the slides if you want.
Yes. My question is, if this polymer is widely used, do you think this gonna be like the new plastic problem where we can find a way to get rid of?
I would say that it wouldn't be a new plastic problems, but it would be the same old problems, since if this plastic ever grown into the market, basically the industry is just going to shift the traditional plastic usage into this 2DPA1 new materials, which have a stronger and more beneficial to the industry usage. So basically, I wouldn't quite gonna confirm that these materials would be a bigger problems in the future, but I would say that if the industry fully adopt these materials, the old one will probably just gonna die out, and it's just gonna come and replace the traditional plastic that everyone use. Yes, thank you for the question, Shinagrit. Oh, also, if I can share the slides for you. Let me share it to the class using this link. Here you go. Okay. And this is the link. If you want to check out this new cool innovation materials, you can go into this Prezi link. Sorry for the transition movement, since the Prezi has a default setting of how it moves or something like that. So sorry for that. It's quite zoom in and zoom out easy thing. So that's it for me. And if any one of you guys have any more questions, you can ask me directly in the group chat. So thank you, everyone.
Okay, thank you.
Let's take a video break and then continue.
Okay.